Okay, should we get started? See how things work this time. Let me begin by recalling the general plan. I'm trying to first defend a naturalistic approach to problems of language and mind. Second, I want to try to show that the most influential currents of contemporary thought that deal with these issues, primarily philosophy of language and philosophy of mind, but also spilling over to cognitive science, that these approaches are both non-naturalist and radically dualist. And I've tried to show yesterday that those are two different things. You could have naturalist dualism like the Cartesians, but these are dualist and non-naturalist, kind of methodologically dualist. And the third point that I want to make is that all of this is a very serious regression, step backwards, since the 17th century, and it should be completely abandoned without a trace left, to put it as strongly as possible. Well, this morning I gave some examples of what I think should be called radical methodological dualism with regard to what are, roughly speaking, philosophical issues. Issues having to do with attribution of knowledge, with the propriety of attributing rule following, and so on. The general conclusion, I think the most charitable conclusion that can be drawn, is that in the major thinking about these issues, we have a series of arbitrary stipulations about certain invented disciplines, one of them called linguistics, the other called philosophy. Linguistics is committed, is instructed by these doctrines that if it wants to study Peter's mind, it must consider only Peter's behavior and maybe people in Peter's community. But it's not allowed to study Wang's behavior, and it's not allowed to study, say, cells. Those steps are ruled out, although any scientist would take them at once along lines that were discussed this morning. So if we agree that that's what linguistics is, the response is simple: just abandon it. It's a ridiculous pursuit, and therefore abandon it, and turn to this other study in which you're allowed to bring in evidence of whatever sort is relevant to understanding Peter's mind, maybe Wang's mind, maybe things about cells or aphasia or whatever. So the answer to the first stipulation is simple: let's abandon this ridiculous vocation and turn to a serious topic, which happens to be the topic everybody's pursuing anyway, so it's not a big change. And that takes care of the first point. It's just pointless terminology. With regard to philosophy, philosophy seems to be identified as a discipline that is concerned with something called philosophical explanation, which is different from scientific explanation, and is interested in something called attribution of knowledge and rule following in an invented sense, technical invented sense, namely the sense in which these things turn on access to awareness, access to consciousness. Now, it's possible to invent such a discipline. You can invent anything. That discipline has no connection to inquiry into the nature of the world. It's not telling anything about the world. It has no connection with ordinary usage, which doesn't follow those principles. And as far as I can see, it has no connection with anything. It has a historical tradition. One can see where it got, how it got there. But again, it seems to me a pursuit that has no redeeming virtues, should simply be abandoned. So that's my conclusion about the second one. Well, what I want to do now is continue the discussion, but begin to turn sort of step by step towards cognitive science, not turning now from what are considered philosophical issues, but just seem to me matters of terminological stipulation, turning to substantive issues, more substantive issues, empirical issues. And here, too, there are lots of theories and requirements and so on. So let's continue. One substantive issue, plainly, has to do with the growth of cognitive capacities, the growth and development of cognitive capacities. We know that they change. They're not the same at age 0 as they are at age 12. So some change takes place, some kind of growth, or what's called, in my opinion, rather misleadingly, learning. So say we'll talk about language learning, which I think should be regarded as language growth, analogous to other forms of growth. Well, here we at once run into a kind of dualism of a curious kind, so let's look at it. There's a doctrine that is called innatism, okay, and there's a big debate about innatism. Now, as in a couple of cases I mentioned yesterday, this debate is one-sided. Lots of people write articles denouncing innatism, but nobody defends it. Nobody writes an article saying, I believe in it. Now, I'm supposed to be the main criminal, the one who is the person who's mainly guilty of the crime of innatism, but I've never really responded to any of the criticisms or defended the doctrine, because I haven't the slightest idea what the doctrine is supposed to be. Since I don't know what the doctrine is, I can't defend it. I mean, if the doctrine is that humans are different than rocks, then I agree. Humans are different than rocks. Rocks don't learn how to talk. If it's that humans are different than chickens, well, apparently. I mean, chickens don't seem to learn how to talk, and humans don't seem to learn how to fly. Well, if that's innatism, I agree with it. But I don't understand what there is to be defended unless somebody really thinks that rocks do learn to talk. If they don't think that, there doesn't seem to be any doctrine to be discussed, and therefore I don't understand what the arguments are about. Well, interestingly, these arguments are invariably dualistic. That is, they only refer to cognitive growth. They don't refer to embryological development. So to go back to my example of the chicken yesterday, nobody suggests that the transition from an embryo to a chicken is determined by the character of the nutritional environment. It's like if you change the nutritional environment, you might end up with a dog or something like that. Nobody claims that. And the same is true of everything from sort of conception up to birth. Well, what about after birth? I mean, organisms change after birth too. Well, nobody, I think, believes that children learn to get bigger, say, or to take something that happens pretty far after birth, take, say, undergoing puberty, which happens at a certain age, roughly. I've never heard anybody suggest that children are taught to undergo puberty. They get instruction from their parents. It's about time, why don't you do it, or something. Or they notice that other people are doing it, say other kids around their age, and they're subject to kind of peer pressure. They want to be like everybody else, so they do it. Nobody has ever suggested that. And so on all the way through all development, except for cognitive development. So the visual cortex assumes whatever structure it does on the basis of internal direction. Now, it's not that anyone knows anything about these topics. Nobody has the slightest idea what makes people undergo puberty at a certain age. And nobody knows, really, what makes a chicken embryo turn into a chicken. Some very strange things happen, and they're hard to explain. I mean, for example, a particular cell, remember all the cells of the body have the same instructions, but they do different things in different positions. So somehow a particular cell knows at a certain point that it's got to become a bone, instead of a piece of an eye. And to try to figure out how the cells know that is extremely hard. So it's not that anybody knows the answers. It's just that everyone assumes that it's all determined by some inner program. And the outer environment can have at most very marginal influences. I mean, maybe it can accelerate the development or retard it or something like that, but it can't really change it in any significant fashion. That's just all taken for granted, the absence of any knowledge. And that makes perfect sense because it's obvious from the qualitative character of the problem. You see in all of these cases that the organism reaches a very complex, highly articulated state of development, and it does it on the basis of extremely limited instructions from the outside, and they all do it about the same way. So if you're even semi-reasonable, you assume it's inner-directed. Well, somehow in the case of cognitive growth, you're not allowed to be reasonable. The same thing is true there. In fact, in the case of cognitive growth, we even know more about it. So a good deal is known about the innate structure, actually more than in many of these other cases. But we're not, and the qualitative situation is quite the same. You can show quite easily, I mean trivially, that people are capable of interpreting and understanding and freely using, without any consciousness of strangeness, all kinds of complex constructions that they've never heard, and they've never heard anything like them, and so on and so forth. I mean, that's trivial to demonstrate. A fair amount is known about the initial structure that makes it possible, about the uniformities and so on. Nevertheless, it's considered highly controversial to be reasonable in this domain. And therefore, you have debates about innatism, which means taking the point of view that you take towards a chicken embryo. That's very strange. Again, it's comprehensible on traditional grounds. You know, you can trace it back to traditional religion and, you know, the soul and all sorts of things. But whatever the anthropological explanations or the explanations as a piece of cultural history, it's a view that seems to have no redeeming features. Well, let me, nevertheless, it's very strongly maintained. And again, the most explicit, influential advocate, as in most of these areas because of his enormous influence, is Quine. He's put the point over and over again over the years. Let me take his most recent version, which appears in a book called Pursuit of Truth, that just appeared a year or two ago. And I'll actually write this out so we can have a look at it. What's the chalk? Let me write it and then I'll... What it says is, in psychology, one may or may not be a behaviorist. In linguistics, one has no choice. In acquiring language, we depend strictly on observable behavior in observable situations. There is nothing in linguistic meaning. And remember, meaning just means language generally. That just happens to be the aspect of language that the philosophers are interested in. So we could say there's nothing in language beyond what is to be gleaned from overt behavior in observable situations. Accordingly, the behaviorist approach is mandatory. That's the argument. Okay. Now let's try, and that's an argument that's been repeated over and over the years. This is the most recent formulation of it, and it's been very influential. So let's try it below the neck. Okay, let's go back to the chicken. And I'm going to give a paraphrase, an exact paraphrase, in which I'll just change a couple of words. In the passage from the embryo to the mature state, the embryo depends strictly on nutrition from outside. There is nothing in the structure of the mature organism beyond what is to be gleaned from nutritional inputs. Okay. Therefore, accordingly, the nutritionist approach is mandatory. Biologists must be nutritionists. Okay. Notice that's exactly the same argument. All I've done is replace, nutritional observable situations by nutritional inputs. But the argument's the same. And the conclusion, therefore, is that embryologists should abandon all of this complicated inquiry into how a cell decides to become a bone in one place and an eye somewhere else, and they should really do something much simpler. Just take a look at the nutritional inputs to the embryo, which is going to be really easy because they're about the same for a chicken and a frog and everything else. And if you look at them, that's all there is. That's going to tell you everything. Well, there's got to be something wrong with that argument. I mean, if anybody presented that argument in embryology, people wouldn't even bother laughing. Why? I mean, why is it any more sensible in the study of language than it is in the study of embryology? That's the question that ought to be asked. Now, notice that it's not that the argument is wrong. The argument is, in fact, entirely correct. It's perfectly true that we depend completely on observable behavior in observable situations, and it's equally true that the embryo depends on nutritional inputs only. There isn't anything else, so that's what it depends on. But the question, of course, is what does the word depend mean? What does the organism do with the, how do you spell out dependence? Let's spell out the concept dependence. Well, when you spell out the concept dependence in embryology, you get these complex theories about how cells, depending on the gradient of certain chemical concentrations, know that they're supposed to produce this protein and not that protein. And then after all kind of complicated stuff, you end up with a chicken. Spelling that out is the meaning of dependence. But of course, the same problem is going to arise in language. You've got to spell out the notion dependence. Well, there is a theory that spells it out. That's the theory of basically universal grammar. It's the theory I talked about before, which says there's some sort of a device, which is the internal structure of the language faculty, and it has all these internal parts and properties and so on and so forth. And when it gets observable behavior, what I call data, it spins its wheels in the way which linguists try to describe, and it ends up giving you the I language. And this is the dependence. That's the spelling out of the notion depend. Now, in embryology, you're allowed to do it. In linguistics, you're not. And linguistics means... Now, it's interesting that in this case, he distinguishes psychology from linguistics. In earlier writings, psychologists had to be behaviorists too. And that's connected with the move that I mentioned this morning, which distinguishes psychological evidence from linguistic evidence. And psychological evidence has this miraculous character that it enables you to do what scientists do, but linguistic evidence somehow doesn't. I think that this is just pushing the dualism deeper. You know, when you're looking at things like vision, say, you're not getting really close to the soul yet. So therefore, you can allow science to enter. But when you get to language, you know, you're right at the core of things. Here we have to make sure the barriers are very high, and nothing rational is going to be allowed. Now, I don't want to suggest that Quine is, is religious or anything. In fact, he's a total atheist. He thinks the whole business is nonsense, and he thinks the only thing that exists in the world is elementary particles. Nevertheless, when he deals with the questions, it sort of spells itself out as something very similar to the traditional church. And now that's an interesting phenomenon, because what it's an interesting phenomenon about our intellectual culture. The most naturalistic, hard-headed, scientific people, as they begin to think about things that are close to what traditionally was the seat of the soul, you know, they veer away from rationality. I mean, it's like a particle being repelled by a particle of the same charge. You can sort of start getting close to it, but as you get closer and closer, you move away. And that's a very common feature of the intellectual culture. And it's quite remarkable to see how it shows up even among the most hard-headed, most scientific people. It's definitely worth thinking about for those who are interested in our intellectual culture. Now, the point is, without properties in the internal state, nothing is going to happen when you're given the nutritional inputs or the observable behavior. There has to be some structure to the organism, otherwise it's not going to do anything to the inputs. You give the nutritional inputs to a rock, it's not going to become a chicken. And you give the nutritional inputs to a rock and it won't pick up an eye language. The reason is because something about the internal structure of the embryo and the internal structure of the human brain. Now, Quine, of course, doesn't deny this. In fact, he agrees with it and insists on it. And he even tells us what the internal structure must be. So he definitely rejects the theory that I described, the one that's guilty of innatism. But he has his own theory about what's in here. Okay? He tells you what it is, what capacities the child is allowed to have. And the capacities are those that are spelled out in what is called his radical translation paradigm, a kind of thought experiment. And if you look at it, the child is allowed to identify objects. The child is granted all of phonology. It's kind of an interesting fact, because it's not clear why. But somehow the child is granted all of phonology, so it gets words and phonological representations. It's even granted morphology, so it gets sentences broken up into words. After it gets expressions, like words, which it gets somehow, there's something in here that allows that, the child is allowed to do the equivalent of asking a question, to see whether people assent or dissent when they're shown a certain stimulus and given a certain word. Okay? So you got a stimulus over here, and you hear a word, and you're allowed to ask your teacher, is this stimulus a so-and-so, or isn't it a stimulus, a so-and-so? The case that Quine discusses famously is where you see a rabbit and you hear the word gavagai, and the child is allowed to say that, yeah, that stimulus is or is not a gavagai. Okay, that's all. Then you're allowed elementary induction. Elementary induction is sort of if things work some of the time, they probably work all the time, something like that. If you look more closely, the child is also allowed a quality space. So that's a set of properties, like, say, color, loudness, things like that. It's not really specified, but you're allowed some kind of quality space, and you're allowed a distance measure. So you're allowed to say two things are closer in color, close. A is closer in color to B than it is to C. Actually, I cheated a little here when I said you see a rabbit, because of course all you see is some visual presentation, okay? And in fact, the core of Quine's theory is there's no way for the child to know whether that visual stimulation is a rabbit or, the tail of a rabbit, or a rabbit against the background of a bush, or a stage in the growth of rabbits, or whatever. Anything that's consistent with the stimulation is given by the assent relation here. Okay, and from that's radical translation. That's the whole story. And that's the structure of the organism. So, of course, Quine has a theory of the structure of the organism. He's not saying it's a blank slate. That would be absurd. Because he recognizes, in fact, that would be absurd. But notice we've just gone from one absurdity to another. This is a theory of the organism, and it's an empirical theory, right? It's got to be treated like any other empirical theory. And the theory is so ridiculous it isn't even worth looking at. We know for certain that nothing like that is the structure of the organism. There isn't any reason whatsoever to take that theory seriously. There isn't a particle of evidence that that's what people are like. And insofar as we know anything about them, they're not like that. So therefore, the theory is not worth looking at. The theory is presented purely a priori. No evidence is given for it. There's no indication of how you might proceed to find evidence for it. It's just stipulated. This is the theory. This is what organisms are allowed to have above the neck. Even if by some miracle it turned out to be true, it would be a totally irrational step. In other fields, you're not allowed to just stipulate a priori what the structure of some system is, because that's what it looks like, and that's what you like or something. You're not allowed to do that. If someone came along and stipulated the structure of a chicken embryo, even if by a miracle they turned out to be right, people wouldn't pay any attention to it. If you propose a theory, you need some arguments. You need some evidence. You have to say, why is it this and why not something else? So, in fact, this is just the purest form of irrationality. It's true that there is a structure to the organism, but there isn't the slightest reason to believe that that structure has anything to do with the organism. And in fact, when you try to apply that structure, you get into all sorts of crazy conclusions. You find that you cannot possibly explain what people in fact know. What people in fact know isn't accounted for at all by this. We have overwhelming evidence about what they know. For example, in the case of Gavagai, we overwhelm, say rabbit, or whatever the equivalent word is in Catalan or anything else. We know perfectly well that children immediately, actually on one presentation, they don't even need a lot of evidence, take the word, and they don't ask assent-dissent questions. They just hear somebody use the word in some circumstance, and they instantly know, virtually without error or without later correction, that what was meant was a particular animal. Not that animal along with a twig that was next to it, and not a stage of the animal, and so on and so forth. Now, we have evidence as strong, we can accumulate evidence as strong as you like that happens. Furthermore, if that were not what happened, nobody would even understand Quine's discussion. If half the people in the world had thought that rabbit means rabbit stage, and the other half thought that rabbit means rabbit, how would the first half even understand his example? The fact is everybody understands his example because we all made the same move. We all picked out rabbit as soon as we heard the relevant word applying. And furthermore, a fair amount is known about how this happens, about what kinds of entities are picked out, pre-linguistically even, what kinds of object constancy there are, how children, pre-linguistic children, identify stimuli as three-dimensional and persistent, like remaining after they disappear behind a screen and coming out in the right place. They get surprised if it comes out in the wrong place and that sort of thing. There's all kinds of understanding of how children conceive of the world even before they start learning language. And of course, when they start learning language, it relates to the way they've already conceived of the world. And as we go on, we find more and more respects in which nothing of this sort even happens. So we have a stipulation which is completely false, completely easily refutable, and not worth looking at in the first place because it's totally arbitrary. So why does anybody pay attention to it? Why is there an influential tradition, including most of serious analytic philosophy until today, which looks at the consequences of the radical translation paradigm? Now, the radical translation paradigm yields a property that Quine calls indeterminacy, indeterminacy of translation. The problem is that if you're only allowed this much structure, then it's true that the child can't tell whether the stimulus was meant to be a rabbit or a stage of a rabbit or whatever. So therefore, the answer is indeterminate, and Quine therefore concludes there's no truth to the matter. The question, does gavagai mean an actual animal, or does it mean an actual animal with a twig behind it? That's not a question that has a truth value. There's no truth to the question of whether it's one or the other. It's indeterminate, and indeterminacy is to be distinguished from underdetermination, crucially. Like everybody, Quine recognizes that in the sciences, everything is underdetermined. So if you draw a conclusion in the sciences, say, relativity theory, it's of course underdetermined by the evidence. There was plenty of there were in fact infinitely many possible theories alternative to that one that were consistent with all the evidence around. That's the state of rational inquiry. State of rational inquiry is it's always underdetermined. That's what it means for something to be empirical inquiry. If it's not underdetermined, it's mathematics, not empirical inquiry. The only place where inquiry is not underdetermined is where you stipulate in advance what the answer is, and then it's mathematics. If it's an effort to find out about the world, everything you do is underdetermined. But this problem here is supposed to be something beyond underdetermination, something really lethal, indeterminacy, something which crucially affects language and meaning and reference, and so on. And all sorts of conclusions are then drawn about language and thinking and people and so on and so forth. And we're simply told that we're not allowed to consider an alternative theory of the initial state, namely one that works and has scientific evidence supporting it. We're not allowed to take that one. We have to take this one, which is a priori and instantly refuted. Well, that's extremely strange. And how strange it is, you see, if you look more closely even into the radical translation paradigm. I mentioned that the child, incidentally, the way this is usually described is in terms of a linguist, not a child. And remember, the principle is that the linguist has to follow the path of the child. The child depends only on observable inputs, therefore the linguist has to depend only on observable inputs. Well, that's kind of strange to start with. I mean, the embryologist doesn't have to follow the path of the chicken. Okay, like if an embryologist is studying a chicken, it doesn't just take in nutritional inputs and sort of drink the milk or something like that. The embryologist is allowed to do all sorts of other things, but the linguist isn't. The linguist has to follow the path of the child. A hopelessly irrational idea if you think about it, but one which is incidentally never questioned in the field. Take a look at the literature. This has been around for 40 years. There's nobody who's questioned it internally. It's questioned sort of from the periphery all the time, but nobody pays any attention to that. Professional disciplines are very well insulated. That's one of the differences between the sciences and the humanities. Striking difference. In the sciences, you just can't be irrational, because if you are, you're refuted at once and nobody cares about you anymore. But in the humanities, you can be as irrational as you like, because the disciplines are insulated and they don't really have strong empirical evidence bearing on. You can go on for craziness forever, and it happens all the time. It's sort of typical. It's another fact about intellectual history, if you like. I mean, it's not that scientists have better genes or anything. It's just that nature is, tough, doesn't let you get away with nonsense. If you try faking an experiment or making up an a priori theory, people will refute it, and then you're finished. Furthermore, in the sciences, you can't keep doing the same thing over and over for the rest of your life. Your students will start asking questions, and they'll say, why don't you do this? And pretty soon they'll be off learning new things, and you'll be out of the business. In the humanities, that's not true. These are really big differences. In any other kinds of dualism, which are, if you like, part of cultural history, actually it's very striking personally to me where I live. I live right, well, a lot of you have been around, you know what it's like. There are two major universities, maybe the two world's major universities within a mile. One of them is Harvard, which is humanities-based. I mean, it has sciences, but the spirit of the place is determined by the humanities. The oligarchy that runs it comes from the humanities and so on. The other is MIT, which is a science university. I mean, it has some humanities, but they're kind of, around the periphery. And the difference of intellectual character between the two places is just astonishing. I mean, I've been there for 40 years, going up and back between them. And it's like two totally different worlds, in every area. That's why linguistics is at MIT, not at Harvard. And it's, in fact, if you look around the world, it's mostly developed in places where there are no strong humanistic traditions. It hasn't developed in the major universities that have humanities programs. That's true in the United States, it's true in Europe, it's true in Japan, and it reflects something very straight, very obvious. In the humanities, disciplines are insulated, they don't want to change, they don't want to hear, they don't want students to come along with challenging questions. They want to keep repeating the same thing forever. There's a lot of personal power involved you can get away with. You're never going to be refuted. You can tell lies about the French Revolution forever and you'll never be refuted. And the effect is that when new things come along, they're welcomed in the sciences. People want them. You want things to be shaken up because you want to learn something new. But in the humanities, it's frightening. And therefore, they're sort of pushed aside. I don't want to say this is 100%, but the tendencies are very striking. Let's take a look at the radical translation experiment. Let's agree to what is completely irrational, namely that the linguist has to follow the path of the child. Okay, so I described it as something that the child does. Now we have the linguist coming in to study the community from the outside. Okay, so here's this jungle community, as Quine calls it. It's off somewhere. The linguist comes from the outside. The linguist is trying to figure out what language they speak. Now, if the linguist was a scientist, what he would do is just what he would do if he was trying to figure out what bird there is in this jungle. The linguist would bring along, as part of the baggage, everything that he or she knows about language. Then you do all sorts of things about language, from studying other languages, psychology, whatever. You have a huge amount of understanding about language. And any linguist who went to study this would bring along that information, just as any, ornithologist studying birds would do it. The linguist would see right off that these things over here are people, just like other people, meaning they're not genetically designed to pick up this language rather than another one, so therefore they fall within the human species, and therefore whatever is true of Chinese and Japanese and Catalan and Swahili and so on is going to be true of these people. So you bring all that along. But the radical translation linguist is not allowed to do this. And that's part of the question I discussed this morning of using information about Wang to draw conclusions about Peter. Okay, you're not allowed to do it. You're only allowed to look at Peter's behavior. And notice that that's true of the child. The child, when the child's trying to pick up its language, it doesn't bring along information about Swahili, because it doesn't know anything about Swahili. But remember, the child has all of that built in. It doesn't have to bring it along. The child has all of that information stored in its brain. The linguist is trying to find out what the child has stored in its brain. The child doesn't have to bother finding out, it already knows it. So that's why, it's really wrong to say that the child doesn't bring along information about Swahili. It does, because the child has universal grammar. just as the chicken embryo brings along information about every mature chicken because it's got it stored in its genes. And the same is true of the child. Well, let's take a look at the linguist pursuing this curious path, not allowed to use anything that has been learned about language, not allowed to use anything that might be learned about, say, cellular biology or, the structure of the brain or whatever, not allowed to have what the child has, crucially, namely universal grammar stored into its head, because the linguist doesn't, the linguist has it as something it can use, but it doesn't have it as something it can study. Like the embryologist has genetic instructions, not unlike those of the chicken, in fact, but those genetic instructions don't help it in studying a chicken. I mean, a human arm is like a chicken's arm. It has one big bone and two small bones, and, happens to have 5 instead of 3, but that's a trivial difference. Then basically 3 digits. That's just like a chicken's arm. So the human embryologist has stored in its genes the answer to the question of how the chicken did what it did, but that doesn't help, because the embryologist is approaching the chicken with its science-forming capacities, not with its gene instructions. In fact, it's trying to find out what the instructions are in the gene. And the same is true of the linguist. The linguist has universal grammar in the genes, but that doesn't help study universal grammar, for the same reason. Well, all right, now we have this linguist curiously handicapped, not allowed to know what has been learned about language, not allowed to use information about the initial state that's been discovered or that's stored or whatever, restricted to observable behavior in observable situations. But of course lacking what the child had, namely the internal structure that made it possible to get something out of that. Well, what is the linguist supposed to do? The linguist now sees this stimulus. It's supposed to hear the word gavagai, and then the linguist is allowed to ask the informants, is that thing a gavagai or isn't it? And it gets a yes or no answer. And then the linguist is allowed to do simple induction, and you end up with indeterminacy. Okay, that's the same course. But now notice what's been presupposed. The linguist was allowed to hear the word gavagai. What does that mean? I mean, all the linguist heard was some signal, some noise. The linguist heard a noise, saw a visual stimulus. How's the linguist get from the noise to gavagai? Well, as any phonologist, any linguist knows, that's a tough job. Getting from a noise to gavagai involves a lot of theoretical assumption. For example, you have to ask, see, this is some kind of phonological representation, quite abstract representation. I mean, for example, you have to know, is that the same noise as something you might transcribe, I don't know, say, kepeki, say. Suppose that comes along next. Is it the same noise or a different noise? Well, you don't know. I mean, depends on your phonological theory. Could be a repetition of the same word. For example, this could be a language which neutralizes voicing and neutralizes front and back vowels and has what amounts to the English vowel shift as an option. Okay, those are all sort of intelligible phonological processes. Maybe that's in part of the optional phonology of this language, so these are the same word. Well, somehow Quine's linguist has gotten over that stage. He's allowed all the kinds of scientific inquiry that tell you that these are different words, or maybe the same word. All of that's presupposed in setting up the radical translation experiment, where you're granted that you hear gavagai. And that's an awful lot. It's not trivial. There's an awful lot of linguistic theory presupposed and granted to the linguist as more equipment. Now, why? Now, of course, you get all the same indeterminacy problems there. I mean, hearing the signal, the conclusion that it was gavagai, well, not some other thing, is exactly as indeterminate as concluding that it was rabbit, not rabbit state. In fact, that's putting it unfairly. We have a lot more evidence here that the child is going to pick rabbit than we do that it's going to pick gavagai from a signal. In fact, it might have picked different things here. For example, it might be the case that the child picked out something that doesn't distinguish these two. You know, I picked a pretty wild example, but you can take less wild examples where existing phonological theory would just say, hearing a signal, you could have picked this range, you could have picked this range. And in fact, that's permitted by phonological theory. However, nothing is permitted by the theory of conceptual development. Here we have very strong evidence that everyone picks out rabbit, not rabbit stage. It's not that there's some communities where they pick out rabbit and there are others that they pick out rabbit stage. In fact, all that was picked out before the child ever heard any language. In fact, maybe built in to start with before any experience, for all we know. So looking at the question naturalistically, we've granted exactly the wrong talents to the linguist. We have not granted the linguist the ability to solve this indeterminacy, although it is solved in the world. And we have granted the linguist the ability to solve this indeterminacy, though in fact it really is indeterminate, not totally indeterminate. Like there is a theory which will ultimately resolve it, but on presentation of a single signal, you don't know. When you hear the first signal, you don't know whether it's in this range or this range. So that's real underdetermination. And there's a science that explains it and deals with it and tells how you converge in one answer or another. Here, there's no underdetermination at all, as far as we know. So to conclude that here we have a problem of indeterminacy, and here we don't, is very curious, very curious indeed. Well, why is the linguist allowed to do that? And why is he automatically granted all the theory that lets you get as far as Gavagai? Well, I think the answer, there's no rational answer. But again, there's an answer that comes out of intellectual history. Gavagai has to do with the sounds, with the perceptual articulatory system. And the perceptual articulatory system is far enough away from the soul so that you're allowed to be rational. But, you know, the concept rabbit somehow is closer to the soul. So we've got that same problem of the particle being repelled as it gets closer to the question. As you get closer to it, you have to veer off into more and more irrationality. I don't think there's any other explanation for this. If you think this is wrong, try to work one out. Try to work out another explanation for why everyone's happy by saying there's no underdetermination in the case where there really is underdetermination, namely the phonology, and there is underdetermination in the case where there really isn't underdetermination, namely the concepts. Why is everybody happy with that? And why is it the basis for, you know, huge theories about humans and so on and so forth? Well, as I say, there is a reasonable theory, wherever it was. Probably erased it somewhere. You know, that one up there, that tries to deal with all of these questions, and both the Gavagai type question and the concept type question, and does so with, you know, reasonable success with the kinds of problems that arise in empirical inquiry. We're told by the anti-innatists that that theory has to be abandoned, not because it's false. You know, it's not, they don't provide any evidence against it. It's just you're not allowed to do it, period. Philosopher stipulates that you're not allowed to do it. Philosopher stipulates that you have to pick this theory, although we know it to be false, and it was totally arbitrary, and the assumptions that it makes are completely irrational. That's where that debate lies. Now, perhaps what seems to be the right theory ought to be abandoned. In fact, very likely it ought to be. You know, chances that we've hit the right theory are very slight. You know? So probably it'll be abandoned. Probably 10 years from now, somebody will have a better theory. That's what we expect. But to show that it ought to be abandoned in terms of something unknown, it does not suffice to require that the linguist abandon naturalistic inquiry. That's not a good enough argument. It's not enough to say you have to abandon the methods of the sciences and you have to accept arbitrary stipulations that I make up. That's not a strong enough argument. In fact, it's no argument. And I stress again that nothing comparable would ever be considered for an instant in the study of other aspects of growth, say a chicken embryo, or for that matter, even phonetics. I mean, if somebody were to come along with similar stipulations in say, the sound side of language, even the philosophers would laugh. But when you get to the conceptual side or the structural side, it's taken very seriously. Well, again, that seems to be a radical form of anti-naturalist dualism. As far as I can see, let me put it in the strongest possible terms, nothing can be resurrected from this highly influential picture. It's kind of a paradigm example of what ought to be avoided in philosophy or the sciences or anything else. As I say, I'm trying to put the conclusion as strongly as possible in the hope that it'll sound as outrageous as possible and lead you to think about whether what I just said is wrong, and if so, why, and if it's right, what it means. Well, let's turn to another issue. Also, we're now dealing with substantive issues, namely language growth. And I'm trying to argue that the irrationality pervades the substantive issues just as much as it pervades the so-called philosophical issues about attribution of knowledge and so on. Let's take another kind of substantive issue, a question that came up yesterday, in fact, in the discussion, the question of reductionism. Okay, so natural inquiry leads to all kinds of hypotheses about the brain of the kind that I roughly sketched out. For example, it leads to phonological theories that tell you what the possible regions are within which that signal could be placed and how you could proceed to decide what's the right region. It leads to theories that give you, the binding theory facts that I spoke about this morning that deal with referential dependency and so on. And it deals with phrase structure, another example that came up, and all kind of other things. It does it by attributing to the brain certain states and certain properties, certain architecture, well understood properties like being a generative procedure, which in fact can be spelled out quite carefully. However, this is regarded as highly controversial and maybe absurd. The reason is that nobody knows how to relate these states and properties to other kinds of description of the brain, say description of the brain in terms of cells. That's largely true. Incidentally, it's not entirely true. A couple of examples have already come up to indicate where it's not true. So there are some things about localization that are known, which are not trivial. For example, as I mentioned yesterday, that localization of the syntactic and semantic processing for sign language appears to be in the same place as where it is for spoken language, which is a very remarkable fact because it's in the left hemisphere, the language hemisphere, whereas visual processing, as must go on in sign language, is typically in the right hemisphere. So there's something deep about syntactic and semantic processing which is localized in the left hemisphere, no matter what the modality is. Luigi mentioned this morning some other things. Some results by Karamazza on differences between inflectional and derivational morphology associated with particular kinds of localizable brain injury. There are other examples, some of them kind of striking. Let's have a look at one. This one has to do with some recent studies just recently published on what are called ERPs, that stands for event-related potentials. It doesn't matter what they are. It's just some measure of electrical activity of the brain. Okay. It turns out that when people are doing different things, thinking different thoughts or saying different things and so on, the brain is always producing tons of electrical activity, and you can measure it now. There's sophisticated techniques for measuring it, for extracting signals from noise and so on. And it turns out kind of remarkably that you can find quite distinctive patterns associated with particular properties of thought and language. So, for example, it's been known for some time that what are called semantically deviant sentences, things like colorless green ideas sleep furiously, that kind, or, I ate the house, or something like that. When people hear those sentences, the brain produces a specific characteristic electrical pattern, which is like a mark that some semantic confusion took place. Notice that that fact alone would suffice to suggest to us that the semantic indeterminacy theories are way off the mark. I mean, our notion of semantic coherence is so tight that deviation from it even sets off identifiable brain, potential brain, electrical activity of the brain, which is distinctive, a particular pattern that identifies semantic deviance. Well, some more recent work has gone on to find distinctive ERP patterns for several categories of linguistic expressions, which are quite intriguing. For example, it turns out that non-deviant sentences, things like John took a walk in the garden or something, sentences that are semantically deviant. So, John took, I don't know what, a flower, I don't know, some crazy word instead of walk in the garden. Phrase structure deviances, where you break phrase structure rules. Extraction violations of two types. One, extraction from specific noun phrases. It's well known that if you have a sentence like, who did you see? A picture of. This is English now, but there are comparable things in other languages. Who did you see a picture of is an okay sentence. But if you try, who did you see that picture of? It's not any good anymore. Something goes wrong. Okay. And the reason has to do with the fact that that picture of him is specific in reference, picks out something particular. A picture of him is non-specific. And it's very subtle point, because in fact, if you take indefinite noun phrases and you give them a specific interpretation, you get the same violation. So that's one kind of deviance. There's another kind of deviance that's, its technical term is subjacency, and it basically means moving something farther than it ought to move. So sentences like, who did you wonder whether John met are worse than, they sound worse to people than, who did you think that John met? The well-known difference. Now, it turns out that these 5 categories of expressions, non-deviant, semantically deviant, violation of phrase structure rules, violations of extraction from specific noun phrases, subjacency violations, moving something too far, yield distinctive patterns of electrical activity of the brain. Each category yields its own pattern. Okay, so all subjacency violations yield the same pattern. All extraction from specific violations yield the same pattern. Well, that's quite a surprising result in many ways. In fact, it's results that linguists could use to sharpen up their own experiments, because a lot of these judgments are pretty subtle and not terribly reliable. And, they change under all kind of slight changes of the conditions when you change from a finite clause to an infinitive clause. And there's a lot of work on it. And it's by no means settled what's going on there. But you do get distinctive brain patterns, distinctive ERP patterns. Well, remember, our question was a question of reductionism. That's really the wrong way to put it. It's a question of unification. We have a characterization of the brain in terms of computational representational systems, which leads to certain results and explanations and understanding. We have another account of the brain in terms of electrical activity, and here we're beginning to find correlations. We're beginning to find relations between the two. Well, that's always exciting, you know. But think through what these relations mean. It's very much like the case of click displacement that I discussed this morning. These 5 categories of expressions are well established within the computational representational theories. They have a theoretical home. The categories are picked out because of properties of the theories. There's evidence about them from lots of different languages. In other words, they're embedded in theoretical understanding. Therefore, they're significant, and there's all kinds of evidence bearing on them. The ERP results are just curiosities. I mean, it happens that the people studying the brain, who are, of course, guided by these categories, they didn't pick sentences at random. The people who were studied it included linguists, like Andy Bars, who a lot of you know, who knew what to look for. And they found numbers, but apart from the correlation, the numbers are just curiosities. There is no theory of electrical activity of the brain that tells you why these numbers should have any significance. You get all kinds of numbers. These happen to have significance because they correlate with the better understood computational representational theories. So you have a kind of unification, but it's unification from the weak theory to the strong theory. That is, and now we know something about electrical activity of the brain, namely, seems to correlate with things that really exist, namely these categories. I stress this because the standard dualist reaction to this information is going to be the opposite. The standard dualist reaction is going to be, okay, we've now given some support to the linguist's categories because of the ERP results, just as click experiments were misinterpreted that way. But that's complete nonsense. The ERP results are totally meaningless apart from the fact that they correlate with the linguist's results. They're just numbers, you know, curiosities. Okay. Nevertheless, it's a step towards unification, and an interesting one. Well, nevertheless, despite some, so there's been some progress toward. Suppose you had 2 theories. One of them correlated with the ERPs, the other didn't. Would that be evidence for choosing between the 2 computational theories? That's a matter of scientific judgment that you can't give a simple yes or no answer to. But at this stage of the game, my scientific judgment is that at this stage, no, because the ERP results are too isolated. They're just funny numbers. I mean, it could very well be that if you take that other theory and it'll have 10 different categories, you find numbers correlating with that. I mean, until you come along with a substantive theory of electrical activity of the brain in which these numbers are embedded, they are curiosities. So the point you're making is very correct, and I agree with it. I just doubt that we've gotten to the point where we could use the information that way. It's very much like the click experiments. Were you here this morning? Were you here this morning when we discussed them? Yeah. Well, this morning I discussed the Fodor, Bever click experiments and Quine's interpretation of them as providing real evidence for phrase structure as compared with the linguistic evidence, which doesn't provide evidence for phrase structure, it leaves indeterminacy. And what I argued is it's the other way around. The click experiments have no meaning at all except for their correlation with the linguistic evidence about phrase structure. Jerry Fodor interpreted the click experiments as meaning that people displace a perceived click to the boundary of a phrase because he knew what the right answer was. He could have, if the clicks had been heard in the middle of the phrase, he would have developed a psychological theory which said you displace the click to the middle of a phrase. So there was no reason to say displace to the edge of the phrase, except that if you did that, you got the right result. And you knew the right result from linguistic evidence. So now someday the click experiments might be sharp enough to give you some evidence about something. And I think that probably they are, in fact. The correlation to the right result in well-established cases is firm enough so that you can begin to trust the cases in non-obvious cases. In fact, there's inquiry into that. Here's a case that's not obvious. If you take sentences like, John expected Bill to be intelligent. These are pretty peculiar. There are things like that in other, well, in a Spanish example would have a causative, something like John made Bill leave, something like that. There's a real question where the phrase boundaries are. I mean, semantically speaking, the phrase boundaries are around here. Okay. But the point is that this word, Bill, acts like it's the object of the upper verb in many respects. So it's as if the phrase boundaries are here. Okay, so you have kind of conflicting evidence I didn't pick exactly the right Spanish example, but you can fix it up so it comes out right. There's a real conflict about the evidence there. The evidence is conflicting. All right, that's the kind of case where you might turn to the click experiments to see what they say. Since we have evidence that they give the right answer in other cases, we might be willing to trust their answer in this case. And in fact, Bever and Fodor went right on to look at that case, because it's the obvious outstanding case. Unfortunately, the results weren't good enough to tell you much. But it's the right kind of thing to do. And with the ERPs, the same story will be correct. I mean, if these results get solid enough, then any linguist will want to take cases where it's not obvious whether you have a subjacency effect or not, and see whether you're getting the special result. So in that sense, your suggestion would be exactly right. The only question is one of timing. How are we far enough along so that's the right thing to do now? Well, that's a stage towards unification. We're relating electrical activity of the brain to the so far better established theories of computational structure. Well, despite a certain degree of progress in unification, the fact of the matter is that there are huge gaps, just huge gaps between the brain sciences and the ones that look at the soft stuff in the brain, and subjects like linguistics, which really are brain sciences in my opinion, but are looking at the brain more abstractly, kind of looking at matter the way chemists looked at matter in the 19th century from a somewhat more abstract point of view. There are huge gaps. For example, nobody has the slightest idea how a messy object like the brain can create something with the highly refined, extremely sharp, very surprisingly elegant computational properties that seem to be discovered in natural language and uniformly. It looks like a very strange thing to come out of a messy thing like the brain. So strange that a lot of brain scientists just conclude that the linguistics has to be wrong. Jerry Edelman is a good example of a well-known and important brain scientist who simply concludes from this disparity that whatever the evidence is, it's got to be wrong. The brain couldn't do anything like that. I don't think that's a scientifically justified move, because I think much too little is known about the brain. But there's no doubt that the gap is great. And when you turn to things like the creative aspect of language use, the gap is almost infinite. I mean, nobody has any idea how any mechanism that we understand, whether quantum theoretical or whatever, could have properties like ordinary human freedom or consciousness. There, the gaps just seem huge. I mean, you don't even know how to begin to bridge them. So there are tremendous gaps. Well, the existence of those gaps could lead to the conclusion that something's gone wrong, something's amiss, and if so, we ask where. You know, where is something amiss? Well, we don't know. In naturalistic inquiry, what you do is you assume that the better established fields are probably, you kind of hold on to the better established ones, and you start looking for changes in the less well established ones. That could be the wrong move. You know, you're just making guesses after all, but it's the rational move. Well, in this case, the better established fields by scientific criteria are the computational representational ones. The neurological ones are very poorly established. And you can find a lot of things about neurons, but you have no idea that they have anything to do with this stuff. I mean, just guess maybe they do because they're there. And in the case of electrical activity, there isn't much of a well-established theory. So to the extent that something is amiss, that, you know, there's a gap that has to be overcome, naturalist inquiry would say, well, let's tentatively hold on to the quite well-established computational representational theories, and let's see if there's something radically wrong about the way we're looking at the brain when we look at it through the microscope. That would be the rational move. Maybe wrong, but of course rational moves aren't necessarily right, obviously. Well, let's have a look at some analogies. Some of them I mentioned yesterday, just to kind of make this look less strange than it may sound. Analogies are never perfect, but they can be helpful. I gave a couple of them yesterday. One is the classic moment of the beginning of modern science. You had Kepler's law, well established. You had the mechanical philosophy, which was regarded as self-evident. There was a gap between them, as Newton showed. What was abandoned was the mechanical philosophy. It may have been self-evident, but it was just wrong. That's the step that science took. Take chemistry and physics 100 years ago. You had quite good and well-established abstract theories of matter in terms of things like valence, periodic table, differences between states of matter, and so on. You had physics, which was taken to be kind of self-evident, namely particles and fields. There was a huge gap between them. Turned out that the physics was wrong. It had to be radically revised in order to be able to incorporate things like the difference between solids and liquids, or colors, or the chemical bond, or why valence works the way it does, and so on. Take, on the other hand, say still 100 years ago, genetics and biochemistry. Again, genetics was abstract like chemistry, and there was a huge gap. In that case, it turned out the other way around. It turned out around 1950, worked through the 40s, and by 1950, that you could account for a large part of known biology in terms of known biochemistry. So there you had what's called reduction. The other two cases you didn't. You had inflation or expansion or some other thing. Well, if these examples sound too exotic, let's take one that's very much down to earth, a current one that's interesting, very much down to earth, very mundane. This is an example which in my opinion is quite relevant to the cognitive sciences. This has to do with something called nematodes. Nematodes are tiny little worms, very tiny. They have about 800 cells. They have a 3-day gestation period. They have about 300 neurons. the wiring diagram of the neurons is completely known. You know exactly how the neurons are hooked up. The developmental pattern is completely known. You know how a nematode gets from one cell to 800 or maybe 1,000, I've forgotten, whatever the number is. So the developmental pattern is completely known. The wiring diagram for the neurons is completely known. Nobody has the foggiest idea why a nematode does anything that it does. You know, like why does it turn left, or, you know, how does it do this, and so on. So you know everything, you know, but you understand nothing about a nematode. Nematodes are critical for this field of biology because they're the simplest organism, sorry, that's the other way around. They're the most complex organism for which everything is understood, but nothing is understood. You know, that is, all the wiring is understood, the developmental pattern is understood, but you know nothing about what's going on. So it's an interesting problem. Okay, here's some. I'll read you some excerpts from a current research paper on nematodes. Don't bother trying to understand it. I don't understand it either. I just want to give you the flavor. Okay, here's the flavor. It says that nematodes, the guy's trying to deal with this problem, you know, the gap. He says, well, the way to deal with it is to consider nematodes to be abstract computational devices belonging, I'm quoting, belonging to a special class of asynchronous interacting automata, implementing certain algorithms, which he then spills out, with computational and control structures viewed abstractly, organized in terms of abstract constraints and underlying organizing principles, some of them general, meaning universal biology, most of them unknown. He takes a highly modular approach with separate models for development structure varying various functions. They differ in what he calls levels of resolution, from phenomenological models to molecular models. The investigator dismisses connectionist models as inadequate for this 300-cell organism, 300-cell neural system, because they abstract much too far from physical reality, and suggests instead that neurons be treated as cells, quoting, that interact by way of a wide variety of chemical information substances, including neurotransmitters, neuromodulators, neuropeptides, and so on, acting over multiple characteristic distance and time scales, in part not through synaptic junctions at all. All of these crazy systems, he says, are metabolically supported, that is, they have some interpretation in the metabolism, and realized in the molecules, but nobody has the foggiest idea how. Putting it differently, this description of nematodes and explanation of their behavior in these terms is as yet unconnected with other descriptions in terms of, say, cells. And the description may involve the unification, if it takes place, may involve reduction, expansion, modification of the whole business. The unification problem may take any course. Okay, that's nematodes. Now, notice that in this case, there are some temptations that no one falls into. I'll quote some temptations from the philosophical literature about language, but just translated into nematodes. So in this case, nobody constructs Platonistic biology, you know, to say that we have to have Platonic models of nematodes to which a nematode stands in some relation. No one demands that the inquiry has to take account of communities of nematodes, say the social life of nematodes. No one claims that there's no truth to the matter because there will be infinitely many theories consistent with the results of some arbitrarily selected experiment or some stipulation about physical reality. Nobody is tempted to construct a common nematode system to whose principle each worm only partially conforms, or to dismiss all of this in terms of dispositions of nematodes to do this and that under particular circumstances. Nobody is tempted to hold that if a an abstract theory of nematode behavior is given, like, say, the one I just quoted, it adds nothing, I'm quoting, it adds nothing to insist that some mechanisms must correspond to the theory, and so on. Now, all of these are quotes from Michael Dummett, from Quine, from Donald Davidson, in comparable circumstances about languages. And I don't think that these, meeting usually, but that's the case of language that philosophers are interested in. I don't see why the arguments have any more force in the case of a language than they do in the case of a nematode. In the case of a nematode, nobody's driven in that direction. Why are we driven in that direction in the case of language? Well, I think an answer has to be given to that question. Unless the answer is given, then I don't know what it would be. We seem to be, again, in a kind of a dualist morass. The fact of the matter is that whether we're studying organic molecules or nematodes or the language faculty or whatever, we pursue different levels of explanation. We try to find understanding as well we can. We hope that we're going to be able to integrate these levels. So we hope that we're going to be able to integrate chemistry and biology, chemistry and physics, asynchronous interacting automata with cellular biology, eye language, something about brains. We don't know in advance whether the right move is going to be reduction, expansion, change of everything, or something that maybe nobody's ever thought of up till now. Same with electrical activity of the brain and eye language. There's no point discussing in advance what course the unification will take. We'll know when we do it. In advance of doing it, you have no idea how it's going to go. There are plenty of historical examples in all directions. As unification proceeds, it may lead to empirical assumptions, including ontological posits, that look absolutely outlandish today, just as has often been the case in the past, ever since Newton. If so, well, so be it. In the case of language and other cognitive functions, it's common to try to relieve the fear that something's amiss. Everybody feels something's amiss. And there are several common ways of relieving that fear. One of them is by saying, there's a slogan around which says, the mental is the neurophysiological at a higher level. That's offered as a kind of a definition of the mental. Okay, so don't worry about the mental. It's just the neurophysiological described abstractly. That's standard slogan. Happens to be a quote from John Searle, but everybody. Another approach is that we should eliminate the mental. Just forget it. There's one well-known version of this called eliminative materialism. Let me erase. Particularly associated with the Churchlands. two philosophers whose suggestion is that people should stop talking about cognitive function altogether, or language. They should just study neurophysiology. So Patricia Churchland, one of the two, wrote an interesting book, actually, on neurophysiology, which, describes it for the layperson. And the point is to tell philosophers, this is what you ought to be studying. Forget all the mental, thinking, language, all that kind of stuff. Eliminative materialism is the doctrine that says we should only look at the material world, not anything else like the mental. A third move, which is quite standard, is to say you should look at connectionist models. Connectionist models have a different organization. They don't directly do algorithmic processing. They do things in parallel, the systems sort of take form and assume certain forms as a result of continuing interaction with the environment, and they can often do some pretty complicated things. But to say that they don't do algorithmic calculation, which is what's usually said, is not a very clear statement, because from some interpretation they are Turing machines, which means under some interpretation they are doing Turing, algorithmic calculating. But one sort of has a sense of what it means to say they aren't calculating algorithms. They aren't computational representational in the sense of the kind of machines that are standard computers, let's say, standard computers. I'll come back and spell this out more closely for those of you for whom it may not be familiar, when we get more into the cognitive sciences. But one standard move is to say, look, the problem with mental is you guys have been looking at computer models, and you should look at other kinds of models, like connectionist models. Well, those, and somehow in that way, in one of these ways, maybe we can overcome the feeling that something's gone wrong because of this huge gap between mental, let's say, theories of eye language and the physical, theories of cells. Well, from a naturalistic point of view, all of these are extremely strange moves, and it's worth seeing why. Let's take the first. We have an account of many things in terms of computational representational systems. Like we have an account of the phonology of Gavagai. We have an account of referential dependencies and all kind of other things in those terms, and it's a good account with a lot of consequences and results and so on. We basically on faith, purely on faith, we assume that there's an account of those things in terms of atoms, cells. I mean, that's just an act of faith. Of course, nobody thinks that the operative principles are going to be identifiable at the level of atoms and cells. So it's not going to be that kind of account, that's for sure. But people assume that somehow there's some kind of an account of all this in terms of atoms and cells. That's a leap of faith. With a much greater leap of faith, many people assume that there's going to be an account in neurophysiological terms, rather than, say, vascular terms, although the brain is just flowing with blood all over the place. So much blood is in the brain that many biologists who are very skeptical about all of this stuff, plausibly, argue that maybe Aristotle was right. Maybe the brain is really a thermoregulator. It's there to cool the blood. And then it has these side functions of, language and so on. It's not totally outlandish when you look at the amount of blood in the brain. And there's a lot of other junk in the brain. There's glial cells all over the place. Nobody knows what they're for. Furthermore, neurons are cells. They have all kinds of interactions besides synaptic interactions, as pointed out in the case of the nematode. And the special approach of neurophysiology might just be the wrong one. Or the brain might just have other properties that nobody's thought of yet. I mean, there are, very fancy physicists, some of the best contemporary physicists, who believe that contemporary physics is too misguided to be appropriate for the study of systems like the brain, that new physics will have to be discovered to deal with such things. Maybe, we have no idea. But the point is that this slogan, the mental is the neurophysiological at a higher level, intended as a definition of the mental, has the matter backwards. What it should say is maybe the neurophysiological will turn out to be the mental at a so-called lower level, although maybe not, because it may be the wrong place to look. That would be the naturalistic approach. So the first move is just wildly dualistic. What about the second one, eliminative materialism? Well, that's just meaningless. Until the Churchlands tell us what the material world is, we don't know what eliminative materialism is. I mean, they seem to understand that cells are in the material world and words aren't, but nobody else but no scientist can understand that. All we know is that the brain has properties. Some of the properties are it gives rise to electrical activity, like ERPs. Another of its property is that people who use brains can identify rhyme and anaphoric dependence. There are theories about these properties. Some of them are in terms of computational systems. There's no subpart of all of that that's material, at least as far as anybody knows. So until somebody can tell us what's the material subpart of all of this, there is no doctrine of eliminative materialism. Now, we do understand Patricia Churchland when she says linguists and cognitive scientists and so on should stop studying reasoning and thinking and language and so on. They should start studying neurophysiology. That makes about as much sense as telling embryologists, stop studying all that stuff and start studying string theory. Okay, if you're interested in string theory, study string theory. Maybe ultimately string theory will account for neurophysiology, for embryology in some fashion. But to tell embryologists that they should drop their inquiries into what makes a cell decide to become a bone rather than an eye, because some physicists have this nice idea about string theory, would be totally absurd. To tell linguists that they should study neurophysiology is far more absurd, because it's at least possible that string theory might be the foundation for embryology. And so far there's some reason to believe that. But there's very little reason to believe that neurophysiology is the foundation for thinking. Could be true, but we have no real evidence for it. So that's just irrational. Intelligible, but irrational. Whereas eliminative materialism isn't even intelligible. Well, what about the idea that we should move to connectionist models and parallel processing systems? The idea is that, granted that these systems don't work for a 300-cell nervous system where the wiring diagram is known, but maybe by some miracle they'll work for 10 to the 11th neurons where nobody knows how they're hooked up all together. Well, maybe, but one would like to hear an argument. It's often argued, I'll finish with this, that we ought to think about the possibility that maybe connectionist models will someday come along that will do what we do in terms of our rule-based models. And we should consider what implications that possibility would have for the existence of rules. And there's a big literature about this. That's very much like saying to the embryologist, look, maybe someday you guys are working out all of these really complicated theories about how cells decide what protein to produce on the basis of chemical gradients in the environment and so on and so forth. Maybe someday somebody will come along with a completely unstructured theory that doesn't have any of those complications and will explain all the things that you're looking at. So why don't you stop looking at it? I mean, that would be so unreasonable that you couldn't even laugh at it. And it's equally unreasonable to raise the question of what it might imply if some unknown connectionist model that you can't even dream of would someday replace rule-based models which actually work. Let me stop there, and we're right up to the point of getting to cognitive science and its computer models, which is the other standard way of trying to relieve these feelings that something's wrong, and the wrong move, in my opinion.
I was wondering, perhaps people with different models that try to ask the linguist to do something that isn't a natural scientific way feel a threat from a linguist or any linguist who is trying to posit a substantive model of a system that seems to a layperson almost ephemeral. And my other question is that about your comment about humanities and MIT versus Harvard. I haven't studied at Harvard, and I don't pretend that I have, but I was wondering if you are aware of the battlegrounds that go on in, say, graduate schools in humanities about the use of language, and if you thought that was unexciting or not.
You're referring to the postmodernist discussions.
Well, I wouldn't like to refer to it in those terms.
Okay, what terms?
For example, just debates over changing the nomenclature for English department.
To what? To comparative literature
or study of Western culture or
Western
study
culture,
of various
yeah.
cultures.
So these questions about those are interesting discussions going on about the canon, it's called. You know, what should you study? Should you study only, you know, the standard phrase is dead white males, or should you study other things too? Okay, that's a very live discussion going on in the United States. I don't know if it's going on in Europe. Well, the first question, I'm sure you're right that people are deeply concerned about what seems to be the ephemeral quality of the successful theories in the case of language, but they shouldn't be, because everything has been ghostly back to Newton. Ever since Newton, we have known that our intuitive judgments about the way the world ought to be are just wrong. Okay? The world has ghostly properties. The world is ephemeral. It has such strange properties as attraction at a distance, which can't exist, as any sane person knows, but does exist. Maybe it's interpreted in terms of curved space-time, which obviously can't exist, as any sane person knows, but according to general relativity theory does exist. Any sane person knows that a mathematical object, like a vector field, can't have mass, but it does, and on all the way up through science. I mean, everything is ephemeral, because nothing conforms to our intuitive conceptions of the way, common sense conceptions of the way the world works. Well, by now we're used to that, or we ought to be used to that. So if these subjects are ephemeral, that just means they're like everything else in science. But still, you're right. I'm sure that's exactly what bothers people. I'm just saying it shouldn't. At least it's one of the things that bothers them. Now, the reactions usually within the traditions that I'm thinking of, I mean philosophy and cognitive science, are to dismiss this as either highly controversial because of this ephemeral character, or absurd because of the ephemeral character, or for the more tolerant people like Michael Dummett to accept it as what he calls a psychological hypothesis, but not a philosophical explanation, not really getting there. Those are the standard moves. Those are the ones I talked about. On the other issue, that's a very serious question. There is, I mean, the United States, to an extent that's unusual among the countries of the world, maybe unique, has actually dealt to a certain matter, to a certain extent, with the fact that it's a multi-ethnic society. Most societies are very, extremely racist. This is particularly true of Europe, which must be the most racist part of the world there is, outside of maybe Japan. And the racism is so deep in Europe that it's very striking for a North American to come over to see how dramatic the racism is, meaning the hatred of everybody else, even, you know, a couple of miles away, you know, and the loyalty to particular, you know, communities and purist communities and so on and so forth. I mean, the U.S. is bad enough on these issues, but it has come to terms with these questions at a level well beyond Europe, at least the parts of Europe I've seen and know about, France, Germany, and so on, England, etc. And one of the things that has come along in the United States in recent years, there's been a kind of a cultural revival in the last 20 or 30 years. in the United States, to some extent everywhere, but strikingly in the United States. The country's a lot more civilized than it used to be in many respects. Now, this hasn't really infected educated circles very much. They're kind of immune. But the general population has changed a lot in all kind of ways. And one of the ways it's changed is that there's a lot more respect for other cultures and other people, and a recognition that you should accord them some, rights. Now, it's not done very nicely, and it's often extremely ugly, but at least the concepts are around, and the feeling is around that you ought to do it. This is reaching the universities. For the last 20 years, it's reached the universities in connection with the study of what's called canon, meaning what's the course of study that everybody has to go through, the sort of core readings that everybody has to go through. So traditionally the canon has been, you read Homer and Plato and Shakespeare and a couple of other things. I mean, that's the canon. That's what people caricature as dead white males. Okay. You don't read contemporary literature. You don't read literature from Africa. You don't read women's literature. All kind of other things you just don't read. They're somewhere on the outside. They're not in the canon. Well, that's been challenged. People have suggested that we ought to have a much more complex canon in which you don't stop reading Shakespeare, but you read Shakespeare together with, so maybe you read The Tempest, Shakespeare's account of the Columbian conquests, together with, say, Las Casas, or even better, with some of the Aztec chronicles that describe it the way it looked from the points of view of the people who were getting slaughtered. Maybe you should look at the whole business. And similarly across the board. There are the idea is there are a lot of different other forms of human culture besides the canon that has been the ruling aristocracy in the ruling societies. And there's a big fight about this. I mean, it's a huge battle. And I don't think the answers are always simple. Like, if you ask, should you stop reading Shakespeare? Well, sure, you shouldn't stop reading Shakespeare. On the other hand, a lot of the stuff about the canon is sheer fraud. The fact of the matter is, it's true that everybody went through that canon. Like everybody read the Iliad, and everybody read Hamlet, and everybody read the Republic. And 99.9% of the people who read all that stuff don't remember one word about it. It went in their eyes, it came out of their hands when they had to write an exam, and then they forgot about it. So for all meaningful purposes, they didn't read it, because it wasn't related in any way to anything in their lives or in any experience and so on and so forth. And part of the argument in favor of enriching the canon by bringing in a broader range of situations and cultures and so on is that you can make this newer canon alive. You can make it meaningful to people by relating it to things that matter to them. You can show them that when they read Shakespeare, they're reading about things that really happen to people here and now, not just, in Elizabethan England. And that's a different approach to the canon itself, of course. And that interrelates. Well, there's an enormous battle about this. And some of the things that are coming out are really amazing. For example, the cultural conservatives, as they're called, who oppose any modification of the canon, have argued, well, for example, Saul Bellow, contemporary American novelist, he said at one point that he didn't see any point in reading literature from Africa because there isn't any African Proust. Okay, well, I don't know if there's an African Proust or not, but there isn't any American Proust either. So therefore, you shouldn't read American literature according to that. And that kind of stuff is coming along all the time. There's also extremism at the other end. There's a fringe that says, let's toss off everything and just study rap. I mean, that fringe is so marginal you can't even find it. Most of the discussion is in a sort of a sane middle range. And it's dealing with real issues. I mean, as my comments may hint at, I think there's a lot of reason for enriching the canon. Enriching it in two directions. For one thing, teaching it so that it's meaningful, not rote learning. And for another, broadening it to include a much broader range of cultural contributions. But exactly how to do that is not so obvious. And there's plenty of ground for discussion about it.
The word canon is not more canon. Canon is not more a canon. A canon must be short, otherwise it's not a canon.
Correct. It's a canon in quotes. It's a collection of alternative paths that you can take through human culture.
If I remember well, in his nothing to do with this. In his characterization of the properties of the organism or the mechanism, I think that Quine had to add a kind of ability or disposition for learning something, to make associations, right? I mean, he couldn't otherwise. He couldn't account for why.
That's true.
For certain, why I can speak and not a monkey, let's say.
He adds what he calls conditioning.
Now, what is not
whatever that is.
What it has not been clear to me is what the status of this ability is. I mean, what?
Nobody else knows either. There are various precise notions of conditioning. So there's Pavlovian conditioning, but he doesn't mean that. What he probably means is operant conditioning, Skinnerian conditioning. It's an experimental situation in which you increase the probability of a particular response by rewarding a certain performance in the presence of a certain stimulus. Okay, so you have a red light. You have a pigeon over here. I don't know how to draw it, so I'll write pigeon. You have a red light. You have a place where the pigeon can peck. And if the red light flashes and the pigeon pecks after the red light flashes, it'll get a piece of corn. If it doesn't peck, if it pecks at some other time, it won't get a piece of corn. Okay, that's the experiment. And what you observe is that the probability that the pigeon will peck when it sees a red light increases. Okay, that's called operant conditioning. That's all it is. It's reinforcement. Yeah. The fancy word is operant conditioning. So he does assume that. Actually, there's some interesting things there are interesting questions about whether this phenomenon exists. It's not at all obvious that it exists, but at all, even for animals. In fact, that's been known for about 30 years. But I'll describe the problems, if you like. It may be a pure experimental artifact that's contrived under certain experimental designs, but isn't really happening. I'll explain why in a moment, but go ahead.
The ability or disposition he talked about should be different from the ability to peel a banana, say, which is something that a monkey can do. And
it doesn't even go that far. The ability to peel a banana goes beyond the framework that he described.
Yeah, but then he says that, like, that's my reading of Quine, okay, which is we learn like pattern sentences and then we associate, right? So the ability to make those associations.
Well, somebody could have that theory, but he doesn't. I mean, that would be kind of Humean theory. But Quine is under the illusion that Skinnerian operant conditioning theory replaced all of that. So he does not accept classical associationism, except in one partial respect. the quality space and the distance measure gives you a kind of associationism. Like it says, if you're trained to react to a certain point in the quality space, there's a certain spread, and you may be partially trained to something that's near it in the quality space. So you're trained to do something for a bright red light. You may do it to a lesser extent for a less bright red light. That kind of association would fall out of it. I mean, nothing changes if you add association. Nothing, We're still at ground zero. Nothing happens, no matter how much of this stuff you add. In fact, nothing happens for animals either, contrary to what's commonly believed. You can't account for anything that animals do in these terms. The classical conditioning experiments don't even work for animals. I mean, they work when you set the experiment up to make them work, but they don't work if you modify the experiment slightly. So, for example, years ago, it was learned, first of all, we might ask the question, why did this design that I just erased have the pigeon pecking as a response? Why not some other response? Well, the answer is that pecking is an innate response for pigeons. They just peck. They go around pecking all the time. So you pick out an innate response, and that's the one you try to modify. Now, that fact is not so trivial as it sounds. All of this shaping of behavior is shaping of innate behaviors. It's taking certain innate patterns of behavior and introducing slight modifications to them. And those modifications are indeed very slight. And just to illustrate how slight they are, the person who worked this stuff out in the most sophisticated way was B.F. Skinner, it's his point of view that Quine has essentially taken over. Skinner was extremely effective in training animals. So most of the animals that you've seen on television, like the dolphins that, in television shows and that kind of stuff, they weren't trained by Skinner, but they were trained by his students. Skinner's students, a lot of them went into animal training, because about the only thing the stuff was good for was training animals. It didn't teach you anything, but it was a good device for training animals. Two of the best animal trainers, the ones who trained most of the famous performing animals, were two students of Skinner's named Breland and Breland. Well, male and female Breland, I've forgotten their names. And they set up they were, got their PhDs, and they set up a training school for animals. And as they pursued the training, they discovered something quite intriguing. They discovered that, in fact, the experiments worked up to a point. So, like, if you were trying to improve here's one case that they were trying to do. They were basically trying to train circus animals. So one thing that they tried to do was to train a pig. Okay, so you've got a pig over here. And the idea is that the pig is supposed to pick up a coin that's lying on the ground and stick it into a slot over here, which is like a mailbox or something. And then it gets, whatever pigs like, I don't know, gets one of those things. So that's a standard conditioning experiment, a little more intricate than what I described before. The pig kind of moves around randomly, and ultimately by accident it picks this up, and after a while it sticks it in there, and it gets a reward, and then maybe that increases slightly the probability, and so on. The way the theory is supposed to work, all irrelevant behavior is supposed to be filtered out, and after you continue the process, the pig is just supposed to go straight to the coin, put it in the slot, and get the reward. That's what's supposed to happen. And if you measure the progress in the experiment, you do get the predicted progress. So it continues to improve in its performance up to a certain point. At that point, it starts to fall off and get way down to the point where it starves to death. What the pig starts to do is, after a while, instead of just picking up the coin, it starts to what's called in English root. I don't know what the word is. It's what pigs do when they go for truffles. They dig in the ground, That's the pig's instinctive action. It's trying to get a truffle out of the ground, so it sort of digs at it. And that's what they start doing. Instead of picking up the coin, they start rooting. And then, of course, it takes longer for them to get the reward, so they get hungrier. And then they root more, and they get even hungrier. And finally, all they're doing is rooting, and they starve to death. So the performance curve goes up to here to a certain point, and it goes all the way down to death. Well, what's happening is perfectly obvious. The reason why they picked in the experiment, picking up a coin, is because picking up things off the ground is a thing that pigs do. But of course, as the pig began to, interpret all of this as having something to do with being fed, as the reinforcements were established, it started invoking its normal feeding behavior. Now, its normal feeding behavior happened to be counterproductive in this experimental design. And ultimately so counterproductive it leads to death. This is what they called instinctual drift. And they finally decided, it looks right, that the reason the conditioning experiments appear to work is they're always stopped right here. That's where the experiment stops, when you've reached the performance level you want. If you were to continue it, what you would get is that the activity of the bird, or the pigeon, or whatever it is, would get absorbed into its own instinctual patterns, which would be highly counterproductive for the experimental situation and would ultimately lead to disaster. Okay, so that the possibility that there's a strong possibility that conditioning is just an artifact. It's a way of modifying instinctual patterns within a certain narrow frame, but ultimately the instinctual patterns will be taken over. Well, a couple of years after that, some people started studying human conditioning. Oops. There's a guy named Don Delaney, who is a behavioral psychologist, committed behavioral psychologist at Illinois, I think. And he started studying human conditioning experiments. So these are the standard kind. You have a red light. Here's the person. There's a red light. Immediately after the red light, there's a puff of air that hits the person's eye. And the person's supposed to learn he better blink his eye when the light shines. Okay. So after a while, the person starts blinking his eye as soon as the light shines. The standard conditioning experiment. Well, Delaney made the following modification. He took conditioning experiments and divided the subjects into two categories. Those who were conscious of the relation between the stimulus and the, not a reward in this case, but the reinforcement. Reinforcement can be positive or negative. There were some people who were aware of the relation between the stimulus and the reinforcement. I mean, they knew consciously that when you push the button, you're going to get a lollipop, or when you see the red light, you're going to get a puff of air in your eye. They knew it. There's another class of people who just never figured it out. Okay. Now, it turns out that the only ones who were reinforced were the ones who were conscious of it, which means that there's no evidence that reinforcement ever took place. It may be just that some people sort of figured out what's going on and decided, I might as well push that button because I want the lollipop, or I better close my eye because there's a puff of air going to come. Well, that's not reinforcement. That's just solving a problem. I mean, it's solving a sort of a stupidly designed problem, designed in such a way as to mislead a psychologist into thinking that conditioning's going on. Now, he went through quite a lot of literature after this. He was very surprised, because it seems to show that there may not be human conditioning. He went through a lot of literature and concluded that there was no evidence for it. I remember once giving a lecture at the University of Illinois about 25 years ago, and these usual questions came up, and I mentioned his stuff. Sorry, I broke the time span. Before these experiments were done, I happened to be at the University of Illinois, and in the discussion I expressed some skepticism about conditioning and said, I guess it was after Delaney's experiments, and I said, look, doesn't seem to work for humans, but probably works for animals, you know. Another behaviorist psychologist there, named Brewer, asked me afterwards why I thought it worked for animals. And I said, I don't know, it sounds like you ought to be able to do it for animals. And he started investigating that specifically. And it turned out, as you can't ask an animal, are you aware? But he did other things, which made it look very strongly as if the animal was acting conditioned only if it had absorbed, internalized certain information. And if it hadn't done that, it wasn't acting conditioned. So he concluded finally there may not be any conditioning at all. Well, at the moment, there's no real reason to believe that the thing is anything more than an artifact, apart from the fact that it has no implications anyhow, even if it does exist. But that, you're right, is the one addition to the Quine basis that I didn't mention. I didn't mention it because I don't even know what it is.